This house has a well for its water. So I fashioned this water bottle system that has a pump in this cabinet and the water bottles, and it feeds water up into the coffee maker and into the refrigerator freezer for making ice. When the cabinet is closed, you don't see the water bottles, which is nice because you don't see the water bottles. But the problem is you don't realize that they might be running low, and I forget to bring a fresh water bottle with me when I come because I didn't realize it was low. So after not having coffee a couple mornings because I forgot a water bottle, that'll really spike the creative juices, I came up with this idea for a platform that has a load cell embedded in the bottom of it. And so it tracks the weight of the water bottle at any moment in time. I connect that up to a ESP32 or an ESP8266, connect that to Wi-Fi and send it to a server. And then the server will monitor the weight of the water. If it ever gets below a certain threshold, it'll send me a notification to remind me to bring a water bottle the next time I come. Designing these systems and connecting up to a server and sending the data isn't all that hard. But sometimes it'd just be easier to be able to do it all in an editor and a simulator and a debugger or something like that without actually deploying to the hardware. Same way you do in an Android phone when you're developing or do an iPhone. You're often running in an emulator, a simulator, and you're not actually on the target device. And you can do some interesting things that way and speed up your workflow. I didn't think that writing code and running in a simulator was really all that viable in ESP32 at this point. And then I got to talking to the folks over at Flux AI, and they were telling me about their vision of doing simulation and analysis and that sort of thing. And it got me searching the internet for, well, what is the state of the art right now for simulating an ESP32 and debugging on it? While thinking about that, that's when I stumbled on this website called WOKWi. It's an online Arduino simulator. Now, I have zero affiliation with WOKWi. I just stumbled upon it because of this other conversation I was having, and it made me go out and start looking for it. And I started using it, and it kind of blew my mind, and I thought I would like to share, and I thought others might find it helpful to see the sorts of things I've already been able to do in just a little bit of using their website. Now, instead of demonstrating the project that I have going, it's a little more complex. I thought it might make more sense to demonstrate this in sort of a whole hello world sort of idea, where we'll use the Blink sketch, and then we'll connect to an access point. After we've sent the data to the server, we get the response, and then we'll look at the real mind-blowing part of WOKWi, which is the primary reason I'm doing this video. My mind was blown when I saw this part. So this is the WOKWi website, and if we click on more options here, we'll see the list of microcontrollers that they currently support. It looks like they're adding more and more, and it looks like they're refining and updating the simulators that they currently have available. So once we select ESP32 from the list, we're brought into this view, this design view here, which has code on the left and our microcontroller on the right. We can drop down this list of components that we can add to the board. It looks like in Git you can add more components if yours isn't listed here. We're just going to use basic components, so it won't be a problem for this video. Since we're building a Blink app, we'll pick the LED from the list here and put it on the canvas. Then we'll connect the cathode to the ground. Now we'll grab a current limiting resistor from the list. We'll connect digital pin 23 as the output to the resistor, and then we'll connect the other side of the resistor to the anode of the LED. To set the value of the resistor, we change that in design.json here in this tab that's next to our sketch. So we go down, we find the resistor, and we add value to the attributes of the JSON. And the value will be the resistance in ohms. This is an interesting aside, which I actually had probably too much fun playing with, was as you type in the resistance of the resistor here. And by the way, it can be a numeric value like it is I'm showing here, or it can be a string for the number. Both seem to work just fine. But it actually real-time changes the bands on the resistor, so you can see the color code of the resistor as you type in the value. So there's our circuit. We got our LED and our resistor, and now we go to our code, and we're going to put in the basic Blink app that easily found on the internet, but I'll just paste it in here real quick. And for fun, I'll just include a serial print line just so we can see how that works also when we run this app. So now we click Save, we click Run, and there's a little spinner there that you can't hardly see. That shows it's compiling, and once that's done, it'll run the Blink app, and then the LED will be on for a second, and off for a second, and on for a second, forever. To stop the app, we just click the Stop button here. So I don't think that's super hard to accomplish in a tool like this, but let's take it up a notch here and let's connect to a Wi-Fi access point and see how that works. So I'll include the Wi-Fi library, the SSID for this is WOKWi guest, the password there is no password, and then we'll go ahead and just grab the standard connect to access point code. Here's our net Wi-Fi function. We'll just call that in setup after our print line, and then we'll run it again. Speed this up a little bit so it compiles and gets to the connect to the Wi-Fi so we can get on to the more interesting stuff. So there we go. It says it connected to Wi-Fi and it says it has an IP address. But is it really? Can it send data? What if I send it to somewhere that they don't control? Well, let's give it a try. So in the interest of keeping this as simple as possible, I coded this little app up in Java to spit out the hex code of a DNS request, probably the worst DNS client in the world, but it's going to make a DNS request, a UDP port 53 to IP address 8888, which is Google's DNS server, and it's going to request the IP address of google.com. This way we'll see that it's not some spoofed DNS server, that this thing is all implemented in the background, that this is actually doing real network communication to a real server that's not under WOKWi's control, and that we actually get data back. And if you're not familiar with how DNS works, I'm including the code in a Git repo here where it's all hard-coded, pretty static, but it'll show you what each and every field of a DNS request is and make a starting point for you to maybe play around with DNS requests and see how they work on your own. So we run the code, the Java code here, and it'll spit out what bytes it sent to Google's DNS server and also spit out the bytes it got back for the DNS server. For our test case, all I really care about are the bytes that's going to the UDP server, which is there, the 28 bytes sending. We're going to grab those, we're going to stick them in a static byte array in the ESP32 and send those out over UDP and see what happens. So here we go. Here's our buffer with our 28 bytes in it. We're going to pack that into a UDP packet of length 28 in this case, and then we're going to send that out, and then we're going to get a response, and then we're going to see how we can see what we sent and what we received. So we compile it, we run it, it connects to Wi-Fi there, and there's our message where it sent the UDP packet. Now for the part that really blew my mind here. We can open the JavaScript developer console in Chrome in this case. You can do it in Safari or Chrome. And we can type download pcap, open close parens, enter, and it will actually download a packet capture of all the information that was going on in the background even before we sent that UDP packet. So here we go. We see broadcast messages for 802.11. We see ARPs and ICMPs, and I can filter IP address equals 8888, which is where we sent our UDP packet, and we can find our specific packet that we're interested in. So there's our request, and there's our response. We can see the request was for google.com, and we got back that IP address. I don't think they're faking it. This is the real deal. WOKWi has really implemented a simulator that is able to connect to Wi-Fi, send arbitrary packets to some server out there, and get the data back. Very interesting. So we've just scratched the surface. There's the diagram editor, these keyboard shortcuts, which I'm sure will be very handy as I start to use this tool more. Looks like they actually support GDB. I tried it quickly. I didn't quite figure it out yet, but it'd be really great if I could set breakpoints and break on given values of registers and that sort of thing, get memory dumps. That'll be amazing. Looks like it has a logic analyzer where we can monitor up to 8 different inputs. It looks like it actually has some sort of protocol decode. I ran it a little bit. So after you stop the sketch, you download a VCP file which you can load in. It'll be nice to be able to use this instead of hooking up my my physical hardware analyzer that I have here to all the different pins. I would like to be able to actually use it in my Logic Analyzer app that I already use, but if they have protocol decoding, then that's great. Looks like it supports MicroPython, CircuitPython, and then here's some information about the ESP32 features that's implemented and that's not implemented, so this is definitely a work in progress. Looks like they have two different Wi-Fi networks, the guest one and then another one if you want to pay. You can connect to a lot more stuff. I'm not sure what all the limitations are yet, but I am going to find out. And here's the documentation for all those diagrams that we were using in that drop-down list. I'm not sure if this is a well-known tool or not. I found this super interesting. I hope you found it as interesting if I have, especially if you hadn't heard of WOKWi before. Probably worth giving it a try if you do ESP32, ESP8266, or even Arduino projects.